Okay, let's start with the lecture. Hello and welcome to Object-Oriented Programming. We are talking about inheritance today. In German, it's Vererbung. And yeah, we will continue with classes. And inheritance is one very, very important concept to use classes. And at least in my opinion, this is one of my favorite lectures because this is a very, very important concept and a fun topic.
Especially in object-oriented programming.
Yeah. Okay, so we are already in the lecture 4, so halfway through already. As you can see, the remaining lectures, so we have next week one lecture about polymorphism and exceptions, and then the Easter break comes, and then is the 1st of May. So the last 2 lectures are in May, but for the first block, I think after next week, we have all the foundations, so we can start with the first assignment. First assignment is also released next week already. Yeah, let's start with a recap. What Michi and Julia discussed today and what we did last time. This is a special about constructors and all the different types of constructors. I know this is a bit or a lot. What you can do now is, so I'll give you about a minute to think about what the output should be. Maybe you write it down because it's quite a lot. And we will present the results in about a minute.
So it's not a Slido quiz, but simply write it down or think about it. We'll then discuss what is going to be the output.
It's not that easy.
No, it isn't.
It's quite complicated, to be honest. So it's not only 1 or 2 print statements. I think it's altogether like 8 or 9. I think it's 8, yeah. So we have 3 different constructors here. The first constructor is without parameters, printing CTOR. You can assume that this works, as always. And we have a second constructor here with a name. This prints CTOR2. And a copy constructor, which prints CCTOR, or which stands for copy constructor. And we have a destructor here, which prints DTOR. Should we start, or should we show you what's the output? Yeah. Actually, this is the output. Anybody had this? It's quite a lot. So let's go through step by step how this output is created. So I think the first one is the easiest one. We have our superhero 1 created with 1 parameter. So this constructor here is called, and we print out CTOR2. So far, so good. Now we have here on this line a copy constructor called. This explains this CCTOR here because we are calling the copy constructor.
Now
it's getting complicated. Yes. We call a do nothing function and hand over this hero 2. this calls the copy constructor because it's not taken by reference. So it creates a copy of the superhero and the copy constructor is called.
But that's only 3
Yeah,
outputs.
we have one more copy constructor, as you can see. When we return here, it's again not by reference. We return a superhero, not a superhero reference. This means another copy gets created, which means we have another copy constructor call. And now this superhero here dies because the function is over. Yeah. So the first destructor is called, and then in the main, all the other 3 dies. So we have 3 times a destructor from the main. Very, very complicated, but it should show you that constructor calls, destructor calls, and especially copy constructor calls are, hard to follow sometimes. And when we use references, especially in this case here, for example, we are, we don't need this copy in this case, and also it might be possible to add a reference here because it's not a local one when we already create a reference here. So a lot of copies are created, and most of the time we don't want this. So keep that in mind if you hand over objects to functions. In most of the time, I think the reference is the better choice, unless you really want to have a copy of it.
But it's good to see that it just in one line, so the function call here, 2 times the constructor is called. So a lot of stuff is going on implicitly by just calling one function.
Any questions to this? Yes.
The third and the fourth CTOR is passing the constructor as the argument.
Yeah.
Are they the same case?
So you mean this CTOR here and this CTOR here? Yeah. So when we go back, this here means we are calling the function hero2. Yes. And by calling this function, we hand over a superhero, and this creates, or this calls the copy constructor. Now we are inside this function do nothing. We have here a local superhero, a copy, because we already created this copy. And because we are returning here, we create another copy of this copy by calling the copy constructor again. We could return here a superhero reference, then the copy constructor would not be called. We are actually returning the reference. But in this case, here returning a reference would not be a good idea because this superhero is a local variable. So we are returning a local variable, and this is not a good idea. So a reference to a local variable is not a good idea because this local variable gets destroyed as soon as the function or the method is over. Any other questions? I think everyone is confused now.
Yeah.
Okay, so let's go back to the basics and talk about animals again. I think we had animals last time, and we will talk about animals, I think maybe the whole lecture for today.
Yeah, I think so.
And we want to create our own animals. Let's assume we have 3 animals. We have a lion, a fish, and a turtle. Very random animals, yeah. All of them have specific attributes. So all of them have a name and an age, okay? It's the same for all of our animals. And they have behavior. So the lion can run, eat, and sleep. The fish obviously cannot run, but can swim and eat. And the turtle can also not run, but move and eat. So there are some behavior that are similar, so they all have to eat at some point, but move is not similar, swim, run, and sleep. So they are different, but some behavior are similar. So when we would implement that now in classes, we have something like this. We have a lion class with a string name, with an age integer, and the three methods. Whatever they are doing, not our concern now, but we just wanted to implement it at any point. The fish has a name, an age, can swim and eat, and the turtle has a name, an age, move and eat. So when we create these classes, we have a lot of duplicated code. So all the attributes, the name and the age, are the same for all our three classes. And some of the methods are also the same.
This is not what we want, right?
No, because we don't want to do extra work. We are silly.
Yes.
And we want to use inheritance for this. So inheritance basically means find attributes and behavior that all of the classes have in common and put this into another class. So we identified the name and the age is the same for all of our classes, and the eat behavior is the same for all our classes. So let's move all the marked stuff into one base class called animals. So we create an animal class having the name and the age and the eat functionality, so the method. And we call this the base class. And then we create subclasses from this base class. We create a lion, we create a fish, and we create a turtle. And we mark this as a subclass of animal by writing it with this notation. Double colon, public animal. This basically means the lion is a subclass of an animal. And this has some advantages because it can now use all the functionalities of the base class and everything what is inside their class. So we can remove all the things that are already in the animals class. They are not necessary anymore. Because of this inheritance we are using now, the lion has everything from the animal class and additionally a run and a sleep functionality. So basically our class structure looks now something like this. The animal class with the name and the age, and every animal has to eat. A lion can, in addition, run and sleep. A fish can swim and a turtle can move. That's basically inheritance.
One small question, why is it public anymore?
Yeah, we will come to this public here. I waited for this question. What does this public mean? We will come to that in a few slides. Yeah, but this is the basic concept of inheritance. So if you understand this, it's already a very big step done for today. Any questions to this? Not that hard to comprehend, I think.
Yeah, I would have a question.
Yeah?
Can I have another subclass, let's say, for instance, of a lion? So can lion be a base class for other subclasses, for different types of lions? So I'm not a lion expert, but...
That's a good question. We can do that, yeah. So when we go to... Let's go first to the terminology, and then we have I think it's a Slido quiz for that.
Mm-hmm.
But basically, yeah, you can have this kind of structure. But let's go back to the inheritance terminology, because this is what we are always using. I already used it a bit. When I say a subclass or a derived class, I always mean the lion, the fish, the turtle, and they are derived. In German, we say abgeleitet from a base class animal. So we have the base class animal, and we have the subclasses or derived classes lion, fish, and turtle. And very, very important, inheritance always describes is a relationship. So if you can say a fish is an animal, a turtle is an animal, a lion is an animal, then inheritance is the best choice for you. If this is a relationship sounds weird, then maybe inheritance is not the best choice. So, for example, if you say, what's a bad example for a relationship for animals? If you say a cage is an animal, no, they are kind of related, but a cage is not an animal. A cage maybe, or a lion can be inside, or an animal can be inside a cage, but it's not a cage, or it's not the same as a cage.
And also the other way around. So each animal is not directly a lion or a fish or a turtle, for example.
It's only in one way. Yeah. So every animal is not a fish or a turtle, of course. It's only one way. Yeah. Okay, let's go to our first Menti Slido quiz.
Yeah.
Not Menti anymore. And I already give you this on the last slide. This is the UML definition of inheritance. So we have an A class, we have a B class, which is derived from A, we have a C class, which is derived from A, and answering your question from before, we have a D class, which is derived from C. So C is derived from B and the base class from D. And now you should see some statements about this class structure, and you have to mark the correct one. Or ones. I think there are multiple. Is multiple selection possible? Can you have a look? Yeah. Looks good.
So this means I can also have another subclass, let's call it E, and E is, for example, a D.
Let's have a check here. Yeah, okay. Sorry, once again.
I can have another subclass, let's say, for example, we call it E.
E, yeah.
And
it's
E
derived
is
from D.
From D, for example.
You can,
and F derived from E, and so on.
You can have like arbitrary number of class hierarchy here.
Great, so there's no limit. Very cool.
Actually, there are some special cases we will discuss later on. But for the basic ones, yes, there is no restriction. Let's wait a few more seconds.
Yeah, maybe we can reach 50, then we will reveal the answers.
Only at 50. Phew, okay. You set the goal, so now we have to wait.
Yeah. I'm sorry.
Come on, 7 more. We can do that. Maybe I also have to.
Michi, Julia, you also participated?
We have to reach 50, otherwise we're not allowed to continue.
Let's say 45.
Let's.
So.
Yeah, 45. I did great.
One more, perfect.
Yep. Okay. Okay, so what have you said? Wow.
Looks
very good.
Wow.
A is the base class of B and C. Let's go back. Yes, of course, A is the base class of B and C. B is a subclass of A. B is a subclass of A is also correct. Objects of class B have a name. Yes, because they are derived from A and A have a name. Objects of class D have a name. Yes, because they are derived from C and C is derived from A. So also D objects have a name. And all the other ones are wrong. Objects of class D have a grade. No, because D is only inherited from C and A, but not from B. And the last one, A is a subclass of D, is wrong, because A is the base class. Very good. So you already understand the basic of class hierarchy. Now it's getting a bit more complicated because we are working with objects, creating objects, calling constructors, and accessing all the members. So, yes.
Sorry, one question.
Yeah.
So if we had, let's say, additionally for a lion, one more attribute or something, can we still group them together? And I think it's 2 slides before this one. Can we still, group them together and say for a lion, for example, private, and then I don't know.
So, yeah. So the question is if the lion has specific member attributes, whatever, a high or whatever, yeah, then you can, of course, create here also additional member variables. This is also what we can see here, for example. This is a member variable, not a function, and only the B function has this grade, and also C and D can have member variables which only these class objects then have and not all the base classes have. Yeah, you can do that.
And we still put public animal, or do we change something?
You mean this one here? I will come to that in a second. Okay, so we want to access the base class. We have our animal class here with a name and an age. We have an eat function, and this basically just prints out the name and if this animal is eating. And then we have a lion running and sleeping, and when we create our lion and we say Simba.eat, we have not specified a name, so the name is never specified. That's why it's not printed. And we come to this is eating. So we create a lion and we can call this eat function from the base class. So far, so good. What if we now want to access the name from the base class in the derived class?
Does anyone have an idea what will happen here? If you want to access the name member in the subclass lion, which is declared in the base class animal.
This name here is also private. Yes? It won't work, yeah. Good choice. It won't work because it's private. And we cannot access private members from the base class in the derived class. So this does not work. Any ideas what we can do now? I think it was a bit before, yeah. Okay, then it's you.
What did you say?
Just hand it over to you.
I guess my guess is a change public to private by the animal.
Yeah, we could get this also into the public section, but we don't want this because the member variables should always be in the private section.
So technically, yes, we could do that,
Yeah.
but that's against the principle of encapsulation.
Yeah.
We're just going to specify that the name comes from the class animal, so we will animal double semicolon name.
Okay, your idea is to specify that it comes from the animal. So animal double colon name. No, this still won't work because it's still not accessible because it says it's a private member and you can only access private member within the class, so within the animal class, and not you are still outside of the animal class. So you need another idea. Yes?
I'm going to create a getter in the animal.
Perfect. We create a getter here, and is this? Yeah, that's the first solution. Great. So we can create a getter in the animal class, which is public, and which returns me the name. So now I can access the name. Works perfectly.
But is this the perfect solution if we want to derive members from a base
When we
class?
use inheritance, there is a second possibility, and this is called protected. I already showed you this, I think, last time. We can use the third access specifier. So we had private and public, and now we introduce protected. Protected basically means they are like private, but all the derived classes, then they can access them too. This is the only difference. So in this case, the name and the age is still not accessible from outside, except if you are a derived class of animal, then you can access it directly using, in this case, the name.
And to recall from last week, so we have now 3 different access specifier. We have public, which means that the members are accessible from outside the class. So we can use it, for instance, if we have a class with some public members, we can access them, for instance, in the main function. But most of the time we don't want that. Private means that members are only accessible within the class. But as we have seen, we cannot use members in a subclass of a base class. So maybe not always the perfect solution if we want to inherit the members in a subclass. And that's why we also have the protected access specifier, which you already said. We can now use the members in the subclass that were declared in the base class. So great solution and an access specifier that we can definitely use when we are deriving classes.
Yeah. And also in all of your assignments, you have to use this concept of inheritance. So you will definitely also use the protected access specifier a lot. Yes?
Can I prevent a subclass of a subclass to exist the first base class?
Can I prevent to access the subclass of a subclass to access the first base class, the initial base class? There are some ways, but it's not that easy. Let's say it like this. It again depends a bit on what you write here. So what does this public means? So but in general, let's say not. But you can somehow restrict with this keyword here what's accessible inside of the class or what's accessible from the base class. I would say, let's go back, in most of the cases, 99%, you write it like this, public. Because this public means you can access the base class similar to the current class. So we have here the base class access specifier. So basically, in the base class, the public section, the protected section, the private section. And we have here the type of inheritance. So what is written here. And with this table, you can now see that if I use public here, as we wrote it here, all my public elements in the base class are also public. All my protected elements in the base class are also protected, and all the private are private, as I would assume that it behaves. I could also write here protected, and then in my subclass, all my public elements are protected, all my protected elements are protected and the private are private. And I could also write private there, which I haven't used. No, I've never used that because all the public elements are private, so you cannot access them. All the protected and all the private are private. So basically you cannot access the base class, which does not make a lot of sense, but you can do it. And yeah, in most of the cases, you will write it like this. So you will have the usual access by having all the public, all the protected, and the private. But you can somehow restrict what the subclasses can see using this. Just for completeness, as I said, in most cases, you will use it as we have seen here with the public keyword.
Okay. Any questions? Do the access specifiers do protected?
Okay. Then let's get a bit more into constructors and how they work. We now have a bit of different behavior because we are not only creating a class, we are creating a class, so for example a lion, that has a base class. So we are maybe have to create two classes. Let's have a look at that. Similar example as before, we have our animal class with the name and the age, we have an eat function, and we have a get name here, and the lion additionally can run and sleep. When we do it like this, everything worked fine because we have a default constructor for the lion, because we have not specified a constructor, so there's always a default constructor. So I can create a lion, and the animal also has implicitly a default constructor, so this works. But what if we have something like this?
So, which of these constructors are called? If both are called, or multiple times, in which order? It's going to be very interesting to see that.
Yeah. So again, what is the output when we create this lion, which is derived from the animal class? So the basic question behind is the animal constructor called? Is maybe only the lion constructor called? Is only the animal constructor called? Are both called?
Should we aim for 50 again, or is it too ambitious?
That's too ambitious, maybe. Let's aim for 40.
Perfect.
Okay, a few more seconds for you to decide. Yeah, we reached our 40 goal.
Yeah.
Maybe that's the better goal for today. Let's see what you voted for. Yeah, great. It's creating an animal, creating a lion. So both is called. Why? When we create an object like this, so we create a lion, the base class is always created first, and then the derived class is created. And this makes sense because the animal is kind of the foundation of the lion, and the lion built up or built on the animal. So first you have to create the ground, so the animal, the base class, and then you can create the lion on top of it. This means it's always first the base class, then the derived class when you create an object.
Now it's getting
Now
interesting.
we are
yeah.
adding a constructor in the animal class. So in the base class, we are creating a constructor with an argument. Okay, we don't have this name here because we don't have limited space, but you can assume maybe that we want to set this name somewhere. It's pretty much the same, again, creating an animal, creating a lion. Any ideas what happens now?
And to recall from last week, as soon as we declare, or in this case define the constructor in the animal class,
Yeah.
there is no more default constructor. So without any
Yeah.
parameters, doesn't exist anymore in this case.
So, yes. Okay, yeah, the program does not work.
Yep.
One possible answer. Another possible answer would be that the compiler sees that there is another constructor and then calls this one, but you are right. It does not work because there is no default constructor anymore. So when you declare no constructor, there's always the default constructor, and the default constructor is used for creating the object. In this case, we created a constructor with one parameter, so there is no more default constructor, and we wanted to create a lion without any arguments. So maybe the lion part would be or can be created, but the animal part cannot be created because there is no constructor for this.
So this means we have to somewhere call the animal constructor, right?
We have to somewhere call the animal constructor, and how can we call this? So we know the animal is created first. My idea would be, okay, in the constructor of the lion, let's call the animal constructor with the argument, and then the animal is created, and we can do whatever we want in the constructor afterwards. This is unfortunately, again, not a good idea because, as we know from before, the animal, so the base class, has to be created before. And when I'm here in the constructor of the lion is already created. So here it is too late to create the animal part, because as soon as I'm in the constructor of the derived class, so in the lion, I cannot call the animal because it's too late. So the animal has to be created somewhere before. Any ideas where we could call the animal constructor before the lion is created? There was one second way to kind of initialize objects when they are created. Yes. Exactly. Put it inside of the initialization list. And this is now why we showed you the initialization list, I think last time. Because when you use the initialization list, at this point, the lion is not created yet. So we can create the animal first, call this in the initialization list of the constructor, then the animal is created, and afterwards the lion is created and the body is executed. So very, very important. If you have an inherited class and you create your own constructors, you always have to specify this in the derived class in the initialization list. When you do it inside of the body of the constructor of the derived class, it's too late. Use the initialization list, and yeah, I think we said you can use it basically for every initialization, not only the base class. You can also use it for other arguments that are in the lion if there are more member variables. Any questions to this? Because this is very, very important. The name Simba, good question. The name Simba gets lost in here because I haven't defined a member variable name and I do not assign it. Yes, it gets lost. I have limited amount of space in my slides, but usually you should have here a member variable name and set this name accordingly. Yeah, for sure.
Any other questions? Because then, maybe to summarize it again, 3 main takeaways regarding constructors and when using inheritance. Whenever you create an object of a subclass, then the constructor of the base class is called first. So as we had it in this case with the animal. And only after that, the constructor of the subclass is called, in this case, the lion. So that's the first main takeaway. The next one is if we do not explicitly call the constructor in the derived class, so the constructor of the base class, then the default constructor of the base class is called implicitly. And the third one is that the constructor of the base class must not be initialized or called in the body of the constructor of the subclass, but it must be called in the initialization list.
So far, so good.
Any questions to that? Because this is really important when using constructors and understanding constructors in combination with inheritance. Yes?
Can you just use an empty constructor in the base class?
The question is, can you use just an empty constructor in the base class? So you can, of course, write it like this and omit this variable here, so this name, and it works as it is the default constructor. Yeah, for sure. All right, then let's move on to destructors, because we saw in the beginning in the recap for today that destructors are called so often, but we have limited control over this. So when we talk about destructors, this is again a short quiz for you, not on Slido, but just have a look at this code. We have our animal again and our lion again. In our animal again, we create an animal, and now we also have a destructor here, which prints deleting an animal. We have a lion, again creating a lion in the constructor, and in the destructor deleting a lion. We now know that when we create such a lion, first the base class is called when we create it, and then the derived class is called. So first the base class constructor, then the derived class constructor.
Now, does this also apply to the destructor?
That's the question. What are your ideas? I don't know who was first, sorry. Okay, you agree?
Yeah, it was the same thing I wanted to say.
Okay, so the answer is when we create the animal first and then the lion, it makes sense to delete the lion first and then destroy the animal. And this is correct, yeah. So this is the other way around. First, the derived class is destroyed, so the destructor of the derived class is called, and then the destructor of the base class is called. So far, so good. When we, kind of order this once again, and as you can see, we highlight this quite a lot now because it's a very, very common error that you misunderstood when constructors are called, when destructors are called. So once again, first constructor of base class, then constructor of derived class. Then we have our object and we can work with that, whatever you want to do. Then the destructor of the derived class and the destructor of the base class is called. That was it already from destructors from now, and we are quite good in time, but now it's getting the most complicated part, I think. So until now it was just creating objects and destroying objects, pretty straightforward.
Calling some methods.
But there are some cases which are not that easy to handle these classes that have inheritance. Yeah, there is a virtual method or a virtual keyword, but before that, let's start again with kind of a motivation why we would use that. So we have once again our animal class, we have once again our lion class, both have a constructor with a text inside, and then we create an animal called water. So what's new here is that we are not creating a lion, we're creating an animal. So we are creating an object of the base class. Does this work?
In this case, technically, maybe. We'll see.
Let's wait to get 40 once again. Okay. Yes, pretty straightforward. In this case, we didn't want to trick you. It's creating an animal because we just want to create the animal here. And this is basically the output, creating an animal. But when we think of creating animals, should we be allowed to create an animal? So do you can think of any animal that is just an animal and not a specific type? There is no animal which is just an animal. It's always a specific type. We can prevent this to create these animals, so these base classes. And we will see that next week. But it is also connected to what we want to discuss now. Yes?
Could we use that just as a placeholder for later? So create an animal for now of no known type.
The question is, could we use it as a placeholder? Yes, I will come to that in the next slide. Yeah. Okay, we want to create a zoo. A zoo, so our zoo is the habitat of lions and fishes in this case. Yeah, maybe also the turtles, but we have limited space here for our code. So we create our animal class. In this case, they just have one functionality, so one method, and they all have one method. It's called make sound. So our animal, we know that there is no real animal, which is just an animal. So I just added here a placeholder for any sound an animal can do, because animals, or maybe all of the animals, can create a sound, so make some noise. A lion can make roar. A fish can make bloop. So the noises are different, but they can make some noises. So they have something in common. And when we create our zoo, we would need a separate vector. So let's say we create our lion. In this case, we create our lion on the heap. So you can see it now here. Works pretty similar. When we create a usual object, we create this line on the heap with the new keyword, store that in a pointer, and then we create a vector of lion pointers. We call this lions. And then we just push back our lion into this vector. So now we have a vector of one lion pointer inside, and we do the same with our fish vector, creating a new fish, call it Nemo, and create a vector of fish pointers, and then add our Nemo. So we had two vectors, so one vector for each type of element. And when we now, for example, want to iterate over all of my elements, so I had to iterate over all my lions vector to get the noises of all the lions, and I had to iterate over all the fishes, so all my fishes vector, to call the make noise for all of my fishes. We have seen today that they have something in common. So they are all animals. Maybe, and this is what you said before, this works. So the output is raw and bloop.
But yeah, we most of the times don't want this behavior, or let's say this code duplication. It's okay for two subclasses. So that's not a lot of code, but let's assume we have 10 subclasses. So we would have to create for each subclass a vector, add all the elements.
And hopefully our zoo has more than two different types of animals. Yeah. So we want to somehow merge this vector and have one vector of animals, but we want to store turtles, lions, fishes, all in the same vector. So we create a list of vectors, and we can do that. We create a lion and a fish once again, but now we create a vector of animal pointers, and we can add our lion and our fish to this animal pointer vector. Why does this work? Because a fish and a lion both have the common base class animal. So they have something in common. They are both animals, and this is why this one works here. So we can store them together in one vector. Vectors are very, very cool, but they have one kind of drawback. As arrays and most of the data structures, they can only store the same data type. So you cannot add in the same vector an integer and a double. Just does not work in C++. But when you use inheritance like this, you can put into one vector two kind of different objects or classes. And the only thing they have to have in common is they have to have the same base class. And then I can iterate over my animals vector. And for each of the animal, we can see here we get a pointer back because this is a pointer. So we have to use this notation once again. Hope you can remember this from C. Animal is a pointer, so we have to dereferences and access the make noise method. And this is the short notation for this. But the problem is when I execute it like this, I got this output. So
we didn't expect it. So
does it not work now?
I would assume to have again.
So it's two times this generic sound from the animal class, which is printed. But what I wanted to have is, I have my Simba and my Nemo. This is a lion, this is a fish. So they still should do their usual noise for a lion and a fish, and not this generic sound. I hope you can see why this happens, because we are storing animal pointers here. And as soon as we're storing animal pointers here, they are somehow treated as animals and only as animals and not as a lion and a fish. This is why we get the generic sound here from the base class.
But there's
But
a solution for
there's a
this.
solution, yeah. Hopefully there's a solution. Otherwise, it would be completely useless
Yeah.
to show this. We just need to add a keyword here, virtual. This is all the magic. This virtual keyword then creates us a raw and a blob. So we will come to the real make noise here of the lion and the fish. What does this virtual mean, Sebastian?
It's a very good question. Whenever we use virtual, so we define a method as virtual in the base class, this means that the derived classes, or let's say for the derived classes, is allowed to use this particular function again and then override this function to have a specific behavior for the subclass. So it depends on the actual type of the object. So as we have had it before with the lion and the fish, these have a different behavior. And whenever we define a method as virtual in the base class, then the behavior of the actual type of the object is used. So we have lion with raw, I think was, and the fish with blob. So it's not the declare type, so on the left-hand side, the animal, but it's the actual data type of the object. But we will probably, or most likely, tell you more about that next week when we talk a lot about polymorphism, what this is, how we can use virtual, and a lot more.
But basically, in simple terms, what it does is when we're iterating over the animals, it sees that this is an animal, okay, it's an animal pointer, so let's go into the animal class, and it sees, oh, there's a virtual keyword. So it might be that in my derived classes, there is another more specific implementation for this type, for example, for the lion. So that does not just take or call this method here. It will have a look, what is this animal in real? The first one is a lion. Okay, let's have a look in the lion class. There must be the same function and a more specific implementation of this function. And then at the second iteration, it's an animal, but again, it sees that this is virtual. Okay, let's have a look what this fish or what this animal really is. It is a fish, so let's have a look in the fish class and call this function here. So this virtual is a keyword that's very important because it tells you on runtime, and this is the key difference to many other keywords. It tells you during runtime, so during the execution, which type of animal it really is, and then it calls the according method. Yes?
Only work in the base class or also in the subclasses? So can I use another version in the subclass and then it concatenates more?
So the question is if you can only use the virtual in the base class or also in the subclasses, you can also use it in the subclasses. We will come to the advantages and disadvantages of virtual, I think in next slide or in 2 slides, but basically you can write it wherever you want. It's a bit, it costs you just a bit of execution time, but you cannot really harm your program. So you can write virtual here. In this case, it makes no difference. But if there is another derived class from the lion, it would be a good idea to write it also here. Any other questions? Yes?
If I have a first subclass of an animal, for example, a cow, and it don't contains the make noise, would it then print nothing?
Very good question. So let's assume we have another subclass. Let's call it cow. And this subclass does not, let's say, have another definition for the make noise method. what would happen? Are there any ideas? Yes? From the, yeah, exactly. So it would just see, okay, we have no method that is defined in the subclass, in the cow class. So let's just take the class that is defined in the base class, so in the animal class. So generic sound would then be printed.
So this virtual is just like an additional offer that you could have a more specific implementation. If not, we will use that from the base class. Yes?
What with variables, when you try to access variables out of the vector with the animal classes, and you want to do specific variables that are not from animals but from the subclasses.
Wow.
Is there the same? Do you have to do that also virtual?
That's a very, very good question. So I think your question is when you have here the animal pointer, but you want to access functionality, so let's say methods or attributes from the lion class. In this case, it will not work. You have to convert it to a lion, for example, and then you can access it. Yeah, but there are, again, some mechanisms to overcome that, but in general, you have to convert it, so cast it, as we know it from C, and there are also C++ casts that we will, I think, introduce maybe next time, I don't know, to convert the animal to the lion. So you have to be sure there's a lion, of course, and then you can make use of all the functionalities that are only implemented here in the lion.
Any other questions to virtual?
Okay, there is another keyword, and let's assume that's why it's black there. Let's assume we cannot see the animal class. How can we identify that this make noise and this make noise is already defined in my base class? Of course, I can look it up, but I have to inspect another header file, and maybe I'm very, very lazy.
Yeah, again,
so,
for one method would be okay, but for 10 or 100, yeah.
I want to have somehow here marked that this make noise is a second or another definition of a function of a method that is already in the base class. And we can do this with this override. And this override identifier is or has two benefits. The first one is, of course, it improves your code clarity. It's easier for you because you can easily identify, okay, this one is override, so I don't have to look into my animal class. I know that in the animal class there must be a make noise method. Otherwise, it won't compile. And this is also the second advantage. At compile time, we can check if there is really a make noise in the base class. So maybe I have a typo inside, it won't work, or the signature is somehow different. So then the compiler tells me, you want to override a function from the base class, but actually you don't do that because there is no make noise in the base class. So please make sure, maybe you have a typo or whatever else. So it's on the one time a safety mechanism for you, and it improves code clarity. This is again one of the keywords, like for example const, that restricts you a bit as a programmer and has no real effect on the program itself, but it helps you in large projects a lot because this restriction at one point will benefit you when writing the code and creating a huge code base of, let's say, 20 classes.
And in addition, again, it can avoid unwanted behavior
Yeah.
that may be introduced to, let's say, typos or something similar.
Yeah. Once again, for example, you change in the derived class the signature and say, okay, now I want to have a parameter in this make sound for whatever reason, or I created it without parameters, you want to add a parameter, and now we would get an error because it says this make noise is not the same as this make noise because it's now another function signature because the parameters are also included in the signature. So even if this is virtual, we cannot come to this make noise function here when we want to have a fish class. So this override here helps us if this make noise is somehow different to the implementation in the base class. All right, I think that's the last quiz for today. We have our usual animal, lion, and fish class. We have constructors with no content, and we have destructors. We will come back to destructors now one more time because there is another interesting behavior with destructors. We create our vector of animal pointers and we push back a new lion and a new fish. And then, yeah, basically it's a bit useless. We iterate over it and we have to delete it. Why do we have to delete it?
Because we have created it with new.
Yeah.
So,
otherwise we have memory leaks.
yeah. And we don't want any memory leaks. I'm really curious about the responses now.
Yeah, it's pretty much as similar as a concept we already have seen. What kind of destructors are called? It's maybe a combination of all we discussed in the past
Perhaps.
hour, yeah. Let's wait for 40 again. Few more seconds. One more, and then yes, perfect. Let's see what you. Oh, okay.
Yeah.
You said delete lion, delete animal, delete fish, delete animal, which would make sense. But why not?
Yeah.
Why not? So the correct answer is delete animal, delete animal. There is one problem again. We have an animal vector here, animal pointer vector. So when we iterate over this, we are again only catching the animal part of the lion and the fish. Remember back when we called a function, we were only having this generic sound. What could help here? What helped last time to fix this generic sound issue and having the real derived class implementation? Yes? A virtual constructor?
Almost.
Almost.
Yeah.
Not the constructor. Yeah. A virtual destructor would help here. So we have to add virtual here to the animal. The behavior is pretty much the same as before. It works the same as our make sound from before. When we add here this virtual keyword and we iterate over the animals, when the destructor is called, and the destructor is called as soon as we delete here, so we basically free the memory of this animal, the destructor is called, and with this virtual keyword, it sees that, okay, it's virtual, so it seems that there is a derived class. Let's see what this animal really is. It's not only an animal, it's a lion. So let's go into the lion and then call the destructor from the lion and then call the destructor from the animal. So when you do it like this, you will have delete lion, delete animal, delete fish, delete animal. First, again, when we delete an animal, or when we delete a lion, first the destructor of the derived class and then the destructor of the base class is called, the other way around, as we have seen at the construction. And with this implementation, you also would have no memory leaks, because when we go back to this one, you would only remove the animal part of the lion and not the lion part of the lion. So when you have member variables here, when you have a vector, whatever, this will not be deleted and you will get memory leaks then. So this virtual here saves you also from memory leaks. And it's again pretty much the same as with the methods before. One more virtual to be safe, to be honest. So write all, maybe not all, but if you have the idea that you will at some point derive this class, so it will be derived from or to any other class, create or make the destructor virtual. It helps you a lot of debugging time, because it's very, very hard to find these errors which you have a memory leak of maybe a lion because only the lion part is not deleted. Very hard to debug. I had to learn it on many times on the hard time. Yeah. Okay.
Yeah. Behind this lies the concept of early versus late binding. So we distinguish between early binding, which means that we associate a function with an address at the compile time. So whenever we compile a program, this means we already know, okay, this function is going to be called. And in contrast to early binding, we have late binding. We also call this runtime polymorphism, and this means that the function pointer, so the function itself, is assigned to a specific address, not during compile time, so when we compile the program, but during runtime, so when the program already runs. And this is a great advantage, let's say, when we use virtual, to not have to know the addresses of the function at compile time, but we can use the possibility to have a dynamic assignment of functions during the runtime.
Yeah. So depending on the type.
Exactly, yeah.
How does virtual under the hood work? So we will discuss that next time in more detail, and it has a lot of advantages. So in the background, a so-called virtual table or V-table is created for every class with virtual methods, and there is in this table always a pointer to the reference or to the correct function. This has one disadvantage, because this V-table has to be created and stored somewhere, so you have a bit more runtime costs and storage costs, but at least in our course, I think it's neglectable.
Yeah. So there is an overhead, but it's definitely worth it, at least in this setting here.
Okay, so virtual. if we want to override a method in a subclass, you have to mark the method or the destructor, as we have seen, in the base class as virtual. Mark the destructors as virtual, otherwise you might get memory leaks, and use also this override because you can explicitly define which function in the derived class should be overwritten. No, which function in the base class should be overwritten. And as I have said before, this virtual has some runtime costs, so maybe your program take a few milliseconds longer, but for our course, it's perfectly fine, so we can neglect this, and using virtual has a lot of benefits.
Are there any final questions to virtual, to inheritance in general? Because otherwise, yeah, we're done with the lecture for the day.
Yeah.
We will have a deeper look into virtual, into polymorphism, also exceptions next week. And yeah, we are looking forward to explaining these concepts to you.
Okay, then thanks for being here and see you next week.
Thank you.